All right, so we are trying to solve again another problem which appeared in JEE Main 2019. And this problem is actually talking about finding the locus of the points which are given by this set. So it's a set given in such a way that the points are actually in this form. So it's saying all the points in this set alpha plus I upon alpha plus I upon alpha minus I, where alpha is element of R and I equals to square root of -1, lie on all these options are given. So first of all, as in this is set of all points, right? So what we have been given here is this alpha plus I, and this is upon alpha minus I. So what we can understand, this is basically gonna be a complex number, and all those points which are gonna be represented will be on the Argand plane. So we'll have to figure out all those points which are gonna be represented on an Argand plane. So first of all, let's try to simplify it, because this is actually representing all those points which are there on this plane and could be represented as x plus iy, right? So why don't we start writing this in the form so that we could compare x and y and then find a relation between x and y, so that this will be easy for us to identify. So we will first multiply by the conjugate of alpha minus I, which will be alpha plus I upon alpha plus I, and that will be equal to x plus iy. And that is again going to be equal to alpha plus I whole squared. And this will be a minus b into a plus b, which is a square minus b square. And that is still equal to x plus iy. And I could write it as alpha square plus I square plus 2I into alpha upon alpha square. And this will be plus 1, because I square is -1, and this is actually equal to x plus iy. So what can I say? So let's write in one more step. Alpha square minus 1 upon alpha square plus 1 plus 2 alpha 2I alpha upon alpha square plus 1 equals to x plus iy. Now I can compare these components over here, right? So this is the real part would be equal to real part, which is alpha square minus y upon alpha square plus 1. And then this y would be 2 alpha upon alpha square plus 1. So if somehow we are able to eliminate alpha square from this one, then we'll be able to get the equation. And what we can see here is one relation, which is generally, let me write this in another way first. So we know that a minus b whole square is actually equal to a plus b whole squared minus 4ab, right? So, or we could also say that a plus b whole squared is actually equal to a minus b whole squared plus 4ab. So if you look at here, if I just square these two terms and sum it up, x square plus y square, what do I get? I get alpha square minus 1 whole squared upon alpha square plus 1 whole squared, and then plus 2 alpha whole squared, and upon alpha square plus 1 whole squared. And this is going to be my LCM, alpha square plus 1 whole squared. And then my numerator would be alpha square minus 1 whole squared, and this will be 4 alpha square. So from the above identity, you could also see this is going to be equal to alpha square plus 1 whole squared upon alpha square plus 1 whole squared. And that is actually equal to 1. So what did I get? I get x square plus y square equals to 1, which is nothing but an equation of a circle whose center is at 0, 0, and then radius is 1. So my answer over here is circle whose radius is 1. So hope you have understood this question. If you have any question, then please do ask me in the comment section below, and I'll be happy to answer your queries. Thank you so much for watching this video. Have a good day.